Okay, let's dive right into this and uncover the hidden patterns behind those incredibly frustrating, highly repeated exam questions. Look, if you're gearing up for your Cambridge IGCSE Physics 0625 exams, you already know the deal. Practical data questions can be completely maddening. You spend hours studying the formulas, you perfectly memorize the definitions, but the second you get into that exam hall, it feels like the practical questions are written in some secret code. Well, today we are cracking that code. We're breaking down the matrix of practical data, specifically focusing on free fall, terminal velocity, and ticker tape data. By the end of this explainer, you'll know exactly how to secure those top band marks. So, imagine this scenario for a second. A student sits down, looks at a question about measuring free fall, and writes out a totally logical, straightforward answer about timing the drop and using ticker tape data. They walk out of the exam room feeling like an absolute genius. But then results day rolls around, and they completely bomb the marking scheme. 0 marks on that question. No way, right? But why? It's a huge high-stakes scenario that happens every single year. The physics concept is floating around in their head, sure, but their exam technique is just completely absent. The main reason standard ordinary revision fails is because students just memorize facts. They don't practice navigating the very specific traps the Cambridge examiners set. It's not just about knowing the physics in your brain. It's about proving it on paper exactly the way they want to see it. And trust me, examiners are actively hunting for these common mistakes. They're scanning for missing units at the very end of your calculation. They're checking to see if you totally ruined your final answer by rounding way too early in step 1. You'll lose precious marks for vague explanations, mixing up your graph axes, offering weak practical improvements, or writing a conclusion that literally isn't supported by the data table right in front of you. You have to know how to step over these traps. Okay, so the absolute most crucial point here is precision. And honestly, it all comes down to this one number, 0.5. Whenever you're using a standard stopwatch in a practical experiment, your own human reaction time heavily influences your reading. The absolute best, razor-sharp accuracy you are realistically going to achieve is about 0.5 seconds. Now, think about that for a second. If you're trying to time an object in freefall, the whole thing might literally be over in a fraction of a second. That 0.5 second delay from your own brain and fingers, it completely destroys the reliability of your data for any fast intervals. And this brilliantly leads us to our first quick win. How do we outsmart the limitations of our own hands and eyes? Well, whenever you are asked to measure incredibly small distances or super short time intervals, you must always measure a multiple, and then divide that by the number of multiples to find the average, or the mean value. For example, if an examiner asks you how to find the thickness of a single page in a physics textbook, you definitely don't try to use a standard ruler on one single flimsy page. That's just impossible. Instead, you measure the thickness of, say, 20 pages stacked together, and you divide that total measurement by 20. Doing this instantly shrinks your percentage of error. It's a total game changer. Now, shifting gears a bit, what's really interesting is how knowing simple apparatus rules secures you super easy marks, as long as you use the exact right phrasing. Let's talk about measuring cylinders. When you pour a liquid into one, the surface isn't flat, it curves. That curve is called the meniscus. The trap here, reading it from an angle. To get the mark, you absolutely must state that the measuring cylinder should be perfectly vertical and your eye must be exactly level with the bottom of that curved surface. Oh, and the one sneaky exception is mercury, which actually curves upwards, so for that one you read the top. It's a tiny detail, but it's exactly what the mark scheme demands to see. Okay, we've covered some really great quick wins so far, but hang tight, because in just a second, I'm going to reveal the secret examiner clue that changes absolutely everything about how you evaluate experiments. It's literally the ultimate checklist for tackling the hardest questions on the whole paper. But actually, scratch that. Before I just hand you that checklist, we really need to build the structural framework first so you know exactly where to plug it in. Let's look at this and see how it builds the ultimate high mark answer framework. This is the exact filter you should apply to any 0625 practical question. Every single time you write an explanation, run it through these 4 steps. Step 1, explicitly state the underlying physics concept. Step 2, pull direct evidence or data right from the source page, the graph, or the table. Step 3, apply scientific reasoning to connect that raw data back to the concept. And Step 4, which is absolutely crucial, polish it off using specific examiner wording. If you hit all 4 of these beats in your answer, the examiner basically has no choice but to award your full marks. Now, applying this exact framework to freefall and terminal velocity experiments, we suddenly run into a massive problem. The speed changes incredibly fast. Remember that 0.5-second reaction time limit we talked about? A stopwatch is completely useless here. So, applying step 4 of our framework, the examiner wording, you must explicitly state the correct automatic timing device. For rapidly changing measurements of an object's motion, you have to write down that you would use a ticker tape timer or maybe a data logger connected to a computer. These specific devices take messy human error completely out of the equation. Just look at this side-by-side comparison to see exactly why this framework matters so much. The flawed answer says, I used a timer to watch it fall. I mean, it's super vague, it doesn't specify the exact equipment, and it offers absolutely no scientific justification. That gets 0 marks. Zip. Now look at the improved, top band answer. Used a ticker tape timer to eliminate 0.5s human reaction time error. It names the specific apparatus, and it gives the exact scientific reason for using it. Boom, full marks every time. Okay, let's put your new knowledge to the test right now. I want you to pause this explainer for a second and just look at this experimental design. Try to spot the fatal error. The student wrote, I timed one pendulum swing with a stopwatch to find the period. Based on the rules we just went over regarding human limitations and small measurements, why on earth is this student going to lose marks? Think about it for a second. Did you spot it? Yeah, here is the exact examiner correction. You absolutely cannot time just one single swing, because that 0.5-second human reaction time penalty will completely skew your data. The correct high-mark approach is measuring a multiple. The improved answer reads, timed 10 oscillations and divided by 10 to find the mean period. Timing multiple oscillations is absolutely mandatory to mitigate that human error and prove to the examiner that you truly understand the concept of reliability in practical physics. All right, here is that massive secret clue checklist I promised you earlier. When you get to the very end of a practical question and the examiner asks you to evaluate or suggest precautions or improve an experiment, do not panic. Just run through this specific checklist in your head. They are actively hunting for you to discuss at least one of these 5 things. Identifying uncertainties in the apparatus, spotting weird anomalies in a data table, discussing the overall reliability of the method, assessing the accuracy of the readings, or suggesting highly specific practical improvements. Seriously, memorize this list. It is your ultimate safety net for those tricky end-of-paper questions. Now let's escalate the stakes just a bit. If you choose the wrong timing device from this table, it instantly caps your grade, no matter how perfect your math is. Context is everything here. If the timing need is just minutes or a few seconds, like maybe you're boiling water, a simple stopwatch is totally sufficient. But for very short intervals, you need an automatic timer triggered by a photo gate or an electronic switch. And for rapidly changing continuous motion, like an object accelerating in free fall, you absolutely must specify a ticker tape timer or a data logger. And what happens when you're actually doing this in the lab? Values are changing crazy fast, and you have to manually record data. Detail really matters here. The examiners want to see practical realism. It's a great idea to state that you would work with a partner who watches the timer and calls out right when to take a reading. Or even better, you can mention pressing the lap timer function on a stopwatch. This freezes the time display on the screen for a few seconds while the clock keeps running in the background. It basically ensures your data table stays completely accurate and you don't miss a beat. Okay, let's do a quick recap of the core elements of this matrix code so we can totally insulate your exam answers from those common traps. First, always know how to eliminate that 0.5-second human reaction gap using the right tech. Second, whenever you are dealing with tiny distances or super fast times, measure multiples and divide to find the mean. And third, never, ever just write down the first thing that pops into your head. Always structure your answers using our 4-step framework: concept, evidence, reasoning, and examiner wording. And hey, before we move to the final piece of the puzzle, make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. So, we have covered an immense amount of ground today, and you are now fully armed with the framework. But wait a minute, this creates a massive unresolved problem. You have this ultimate 4-step framework in your back pocket, sure, but how do you know exactly which of those steps the examiner is prioritizing for a specific question? Think about it. If you misread a single word in the exam prompt, you might give this brilliant scientific reasoning answer when the examiner only wanted raw evidence, and guess what? You will still get 0 marks. The deeper code to truly cracking this exam lies in mastering the specific command words. I'm talking about words like describe, explain, evaluate, and calculate. These words dictate exactly which part of the framework you need to use. If you don't know the crucial difference between describe and explain, all the practical knowledge we just covered won't save you. That makes our next explainer on Physics 0625 command words an absolute mandatory watch. So before you click away, leave yourself with this final thought. Have you been losing marks all this time because you didn't understand the physics? Or just because you haven't learned how to speak the examiner's secret language? See you in the next explainer.